doing problem 1A from section 6.1. Okay, so I've got the function written down here already, the interval that's given, and then I found the derivative of the function, and then I factored it. Okay, so remember, to find absolute extrema, we want to first locate the critical numbers. We'll do that by setting these, the factors of the derivative equal to 0. So we'll get x equals -3, and then x equals 2. So those are our two critical numbers. Then we just want to plug all of the values that we have here, the two endpoints and the critical numbers, plug them all back into the original function. So let's do this from smallest to largest. We'll get f of -4, f of -3, f of 2, and f of 4. Okay, so plug all of these numbers, critical numbers and endpoints, back into the original function. So I'll do that on the calculator. So we're going to do f of -4 first. And that gives us -7/3. And when I plug in -3, I get 15/2. And when I plug in 2, I get -25/3. And when I plug in 4, I get -23/3. And for these fractions, you might want to, if you do a decimal approximation or just a decimal representation, it may be more clear which one is actually the minimum and maximum. So let's see, this is about -2.3, and 3's are repeating. Let's do -3 again. 7.5. Could have done that without a calculator. And then -25/3. Get -8.3. And then the 3's are repeating there. I guess that's not approximate, that's exact there. And then -23/3. Get -7.6. The 6 is repeating. Okay, so now I think it's pretty clear which one is the absolute maximum, which one's the absolute minimum. That's the only positive value here, so this has to be the absolute maximum. And then the smallest negative number, or the largest negative number that we have here is this one. So this is the absolute minimum. So remember that these absolute extreme values can occur either at endpoints or critical numbers. In this particular case, both of them occurred at the critical numbers, but again, that certainly doesn't always have to happen. They could occur at the endpoints. Okay.